Good evening, all of you. Today's in the today's lecture, we will study about Zener Diode and its application as a voltage regulator. First, we will study the basics of the Zener Diode. Zener Diode behaves like a normal diode, general purpose diode. Consists of silicon p-n junction when biased in the forward bias direction. Anode is positive with respect to cathode and it behaves like a normal signal diode passing through the rated current. So, Zener diode is in the forward bias. Zener diode behaves like a normal diode, like other p junction diode. It is also consists of the p-type and n-type silicon, and it behaves like a normal diode in the forward direction. But in the reverse bias, its behavior is entirely different from the normal diode. However, unlike conventional diode blocks any flow of current through itself when reverse bias is applied. Up to a particular voltage, the current will not flow from this diode. When that voltage exceeds the reference voltage, that breakdown will occur at large amount of current will flow in the reverse direction. To increase, this is because when reverse voltage applied across the Zener diode exceeds the rated voltage, device process called avalanche breakdown occur in the semiconductor depletion layer and current start flow through the diode limits the increase in voltage. What happens? As we know, the power is equal to product of voltage and current, which remains constant. If we increase current, the voltage will reduce. If we increase voltage, current will reduce. So the working principle of Zener diode, it works on this principle that whenever the applied voltage exceeds the breakdown voltage of diode, large amount of current will flow that keeps the voltage constant across the diode. The current now flowing through the Zener diode increasing dramatically to the maximum circuit value. As Zener diode comes in the breakdown region, large amount of current will flow, as we will see in next slide in the characteristics of the Zener diode. When up to breakdown voltage, Zener diode will no very less amount of current will flow in the microampere. Whenever there is a breakdown blocker, large amount of current will flow to keep the voltage constant. So reverse saturation current remains fairly constant over the wide range of the reverse voltage. The voltage point at which the voltage across the Zener diode becomes stable is called as Zener voltage. And for Zener diode, voltage can range from less than 1 volt to few hundred volts. This is the characteristic of Zener diode. In the forward bias direction, as you can see, it behaves like a normal diode, like other p-n junction diode. It behaves like a normal diode. But in the reverse bias, it up to breakdown voltage, this is VJD breakdown voltage. Up to breakdown voltage, its current is very constant current will flow, very less microampere current will flow. Whenever the voltage exceeds the breakdown voltage, equal to breakdown voltage, large amount of current will flow up to its rated current. So the voltage, excess voltage, whatever comes across the diode, that will produce current and keep the voltage constant. This is reverse saturation breakdown. In Zener diode, the breakdown is due to avalanche effect. Avalanche effect will occur. Electrons collide with nearby electrons due to high electric field, and high electric field collision will increase, and large number of covalent bonds will break, and Zener breakdown phenomena will occur. These are the symbols of the Zener diode. Both types of symbols are usually used in the literature. It's a simple diode and its cathode side, like this structure. This is the symbol of the Zener diode. Zener diode as a voltage regulator. Zener diode can be used as a produce stabilize the output voltage with the low ripple varying low current, very low, very under varying load current conditions. Zener diode works on the principle, as I told you, whenever voltage exceeds the general breakdown voltage, that extra voltage will produce large amount of current, keeping that voltage constant. So it's passing a small current through the diode when a voltage source into when it is not comes in the reverse breakdown region. When it doesn't comes in the conduction, very small amount of current will flow across the diode. The current limiting resistance is Rs is connected across the Zener diode, which conduct sufficient current to maintain the voltage drop E out. You can see the circuit diagram of this. This is Zener diode. This is the load resistor connected to across this Zener diode, parallel to Zener diode. Whatever the current flow through across this is the input current. It will only drop BZ voltage. The excess voltage will drop across this Rs resistance. So you can see input voltage, the voltage excess, its current limiting Rs is current limiting resistance. The extra current will be limited by this Rs resistance, and this is the resistance which is parallel to connected to it. It is keep constant voltage. I think you understand why it is voltage remains constant across the Zener diode. Very simple basic simple principle is applicable here. Whenever voltage increase greater than Zener, whenever voltage exceeds the Zener voltage, Zener background voltage, what happens? Large amount of current will start flow, that keeping that voltage constant Vz, that extra voltage will produce the large amount of current across the diode. This is the basic principle behind the operation of any Zener diode. But why Zener breakdown will occur? Zener breakdown will occur due to avalanche effect in the p-n junction diode. In the p-n junction, the semiconductor, there are large number of collisions will conduct. So large number of collisions will break large number of the covalent bond. So because large number of covalent bond will break, then further they break further bonds. The free electrons hold will break further bonds. So this process will continue and avalanche effect will occur. And due to high electric field present across the junction, so these are the two factors responsible for the breakdown. The resistor RSH connected in series. Resistor RSH connected in series with the Zener diode to limit the current flow through the diode with the voltage source Vs. So to stabilize the output B out is taken from the Zener diode. Zener diode is connected in cathode terminal to positive terminal of the DC supply, and reverse bias will be operating its breakdown condition. So these are diode whenever it is used as a voltage regulator, a voltage reference to keep the voltage constant. It always connected in the reverse bias direction. It will connect in the reverse bias direction. You can see the positive terminal is correct. You can see here is cathode is connected to the positive terminal, anode is connected to the negative terminal. So it is whenever it is used as a voltage regulator, it is always used as a in reverse bias. So this is the overall working principle of the Zener diode. If you face any difficulty, if you face any doubt, if you want further clarification on the working principle of the Zener diode, you can mail me. Yeah, you can mail your doubt. You can call me anytime. One simple principle of the operation of Zener diode, as I told you, whenever this is Zener voltage, whenever this is Zener voltage, whenever voltage across the Zener diode exceeds the Zener background voltage, large amount of current will flow across the diode, which limit the voltage, which keep the voltage constant, and with that is Bz, and large amount of current will flow across this diode. So across the whatever the load connected in the parallel to the Zener diode will remain feel constant voltage Bz, because whatever the extra voltage comes across the diode, that will produce the extra current, but that is called a Zener Zener breakdown, large amount of current will flow across this diode. As I told you, breakdown phenomena is avalanche effect will occur and Zener breakdown will occur due to high electric field present across the PN junction. So these two breakdown will these two factors are responsible. Large amount of, as I told you, high voltage, high reverse bias voltage applied across the Zener diode, that will produce high electric field. So high electric field, due to high electric field and avalanche effect is happened in the PN junction diode, its breakdown will occur. After breakdown, the voltage remains constant and excess current will flow through the excess current will flow from the Zener diode. This is all about Zener diode. Thank you.